one of the most, by and large, observable physicists, Michio Kaku, has discussed his evaluation concerning this issue. Kaku, known for his surprising commitments to the fields of physical science, has as of late recognized that the James Webb Space Telescope has found 6 tremendous infinite frameworks that specialists once thought proved unable to exist. These disclosures have the potential to open up new viewpoints in how we might interpret the universe. It is, therefore, both entrancing and worth watching out for these turns of events. Kaku is a remarkable figure in the logical field, a physicist of American and Japanese heritage. He is seen as an expert in both conventional exploratory physics and quantum mechanics. Unlike some more moderate and distrustful researchers, Kaku doesn't belong to that group and has been open to the astonishing recent discoveries of the James Webb Space Telescope, JWST mission. We are lucky that this recognized analyst has chosen to end his silence and offer transparently what can no longer be denied. The fervor and almost all-encompassing tone of the famous physicist are apparent in his comments on the disclosures made by the James Webb Space Telescope. He proposes that these discoveries have been the component that has stimulated his interest. We should investigate the ramifications of Michio Kaku's disclosure of these 6 immense vast frameworks. Kaku is a researcher who has continuously had the option to consider new speculations throughout his life. He comprehends that Einstein's speculations of relativity and Newton's regulations are deficient to catch the full intricacy of the universe. Kaku understands that the disclosures of the new telescope might actually improve the logical field, despite the fact that many of his peers have not been able to embrace this view. This has caused concern and anxiety among both defenders and critics of quantum mechanics. However, this genuine understanding brings out laughter from Kaku. The JWST has uncovered the discovery of 6 gigantic universes tracing all the way back to the earliest phases of the universe. Each of these vast frameworks contains more stars than our own, despite forming just a short time after the Big Bang. The group of astronomers who made the discovery has named these surprising frameworks universe breakers, as their reality would change our whole understanding of the universe. Something here no longer fits with the theory of the Big Bang. The Big Bang theory lets us know that the universe was a tumultuous spot following the starting event. The primary solid objects took a few 100 million years to form, and it required countless extra years for these objects to come to an adequate thickness to produce light. The development of complicated structures, such as galaxies, was expected to happen much later. Some of the newfound frameworks outperformed the size of the Milky Way, and their gigantic splendor suggests that they were likely forming many new stars each year, while our own galaxy forms stars just irregularly. It remains muddled exactly when the first universe formed. Researchers have not been able to determine this until recently. The one thing that is clear is that at first, there might have been just single stars or groups of stars that eventually came together to form continuously larger structures, eventually leading to the development of dwarf galaxies, which underwent mergers and continuously grew, as demonstrated by past hypotheses. According to these hypotheses, very advanced and huge frameworks could not have existed at that time, which raises the question of whether the universe is simply older than previously accepted, or whether complex, large-scale structures existed much sooner than expected. This present situation is challenging for conservative science, which still struggles with this model. Also, some areas of physics have firmly dismissed this revelation, highlighting potential errors in the age calculations. Kaku, mindful of this, had this to say: there are many instances of old and misleading theories that stubbornly endure due to the prominence of certain scientists. Many of these hypotheses were eventually disproven when fundamental investigation uncovered their misrepresentations. Hence, the vital work in any science, especially in physics, rests with the experimentalists who maintain the validity of research through exact truth. As a matter of fact, on Earth, we have essentially no information on the genuine starting points of the universe. The Big Bang theory was laid out in 1927 based on observations of the universe's expansion. This information led to the conclusion that the universe began from a single point and has been expanding since then. At the time, it was hard for people and scientists to envision a universe with a start and an end. The possibility of a universe that had always existed and was infinite in time was beyond human imagination. Indeed, even today, scientists still face challenges in understanding it. Anyway, it is essential to rethink these possible outcomes. These new insights don't fit at all with what scientists have depended on for years in the Big Bang theory. But science has repeatedly shown that reassessment and openness to groundbreaking ideas are key pieces of the scientific process, as much as the affirmation of specific theories and observations. When Einstein was a youngster, it was trusted that the stars and planets were fixed in the universe and these particular arrangements involved a defined space. Anyway, we now understand that everything in the universe is in motion. Planets orbit stars, stars move within their galaxies at different rates, and whole galaxies move quickly through space, the ultimate fate of which we still can't predict. Today, researchers are challenged to accept uncomfortable insights, and it is understood that hypotheses are not just theories or major insights until they are thoroughly tested or affirmed by definitive observations. The idea of the Big Bang emerged from the confirmation that galaxies are moving away from each other, and this distance is proportional to their separation from Earth. This observation, known as Hubble's law, suggested that the universe has been expanding for a long time. Additional proof, like cosmic microwave background radiation and the redshift of light from distant galaxies, as well as other galactic patterns, appears to support this theory. Anyway, it is important to remember that people who once believed the Earth was flat and that the Sun revolved around us also had similar types of evidence for their doubts, until events or technological advancements provided a clearer and more accurate picture. Present, we are seeing a similar situation. Researchers expected the JWST to confirm suspicions about the Big Bang, but instead, they have found the 6 frameworks that appear to be too large for their age. This reminds us that science is always evolving and experts must remain open to new discoveries and rethink existing theories based on available evidence. Researchers use redshift as a tool to determine specific measurements in the study of the universe. Redshift, otherwise known as the Doppler effect, refers to the change in the color of light as the light source and the observer move relative to each other. To understand this, imagine watching a vehicle coming toward you. As it draws closer, you hear the engine getting louder. However, once the vehicle passes you or moves away, the sound changes. This is because the sound changes as the vehicle moves. The same is true for light. When a light source, like a distant star, moves toward us, the light we see shifts toward the blue end of the spectrum. On the other hand, when the light source moves away, the light shifts toward redder hues. This phenomenon is known as redshift. Physicists have converted redshift values into speeds and distances for estimating quantities in the study of the universe. Anyway, it is crucial to note that small errors in these calculations could have tremendous implications. The measurement methods used in the past are now under review, and the results that researchers will arrive at regarding the latest revelations related to our universe are exciting. It is important to consider whether these results are genuinely based on redshift errors or whether some scientists are simply denying the facts. This is a question that requires serious assessment and careful review of the data and methods used in the investigation. As scientific inquiry progresses, discoveries made by instruments like the James Webb Space Telescope frequently challenge our assumptions about the universe. The ongoing discovery of 6 monstrous universes tracing all the way back to the beginning of the universe is one such example. These worlds, which defy regular speculation of galaxy formation, raise significant questions about the timeline and processes involved with the development of large-scale structures. The James Webb Space Telescope, a successor to the Hubble Space Telescope, is equipped with cutting-edge technologies that allow it to peer further into space with striking clarity. Its ability to detect light from the farthest reaches of the universe provides astronomers with a window into the past, allowing them to study galaxies that formed billions of years ago. The discovery of these ancient and gigantic universes challenges existing models that predicted such enormous designs should have formed much later in the universe's history. The implications of these revelations extend beyond astrophysics and into the realm of fundamental physics, compelling scientists to reconsider established theories about the early universe. These discoveries also highlight the importance of remaining open to revolutionary ideas and changing our understanding based on experimental evidence. Kaku has emphasized the critical role of scientific proof in shaping our perception of the universe, pointing out that theories must continually evolve to accommodate new information. The debate sparked by these revelations mirrors the dynamic nature of scientific inquiry. On one hand, There are defenders who argue that the discovery of early massive galaxies suggests a longer timeline for cosmic evolution than previously thought. This viewpoint challenges the conventional view that galaxies develop slowly over billions of years through mergers and the gradual evolution of smaller objects. On the other hand, cynics caution against hastily discarding established models based on limited observational data. They advocate for a more cautious approach, suggesting that anomalies in data interpretation or measurement errors could explain the unexpected discoveries. Redshift, a phenomenon observed in the light emitted by distant galaxies, plays a crucial role in these critical investigations. As galaxies move away from Earth, the light they emit shifts toward longer wavelengths, a phenomenon known as redshift. By measuring the degree of redshift in a galaxy's light spectrum, astronomers can infer its distance from Earth and its speed relative to our own galaxy. This data is essential for developing models of galactic formation and understanding the expansion of the universe. However, redshift measurements also carry inherent uncertainties that can complicate the interpretation of astronomical findings. As researchers explore the farthest reaches of space with tools like the James Webb Space Telescope, the importance of constantly re-evaluating hypotheses based on new observations cannot be overstated. With each new breakthrough, scientists like Kaku urge their colleagues to embrace the uncertainty inherent in the scientific process. The pursuit of knowledge is a dynamic journey, where even the most established theories can be challenged, refined, or replaced as new evidence emerges. As we await further developments in the study of the universe, the latest discoveries remind us that science is far from a static discipline. New technologies and more precise measurements will undoubtedly continue to reshape our understanding of the cosmos, prompting further questions, debates, and excitement among researchers and the public alike. As we look to the future, the ongoing discoveries made by instruments like the James Webb Space Telescope have the potential to revolutionize our understanding of the universe. These breakthroughs offer a fresh perspective on the formation of galaxies, stars, and other celestial structures. As these discoveries continue to unfold, it is essential for the scientific community to stay receptive to new ideas and interpretations. The shift in our understanding may not only reshape astrophysics but could have far-reaching implications for related fields such as cosmology, quantum mechanics, and even the philosophy of science. The emerging findings also underscore the importance of scientific collaboration. Many of the groundbreaking observations are the result of teamwork across multiple disciplines, drawing upon the expertise of astronomers, physicists, mathematicians, and engineers. This interdisciplinary approach enables scientists to tackle complex problems and analyze data from diverse angles. As we explore deeper into the universe, the necessity for global collaboration will only increase, as researchers work together to answer some of the most profound questions in human history. The future of astronomy holds the promise of even greater discoveries. The James Webb Space Telescope is just one of several advanced instruments that will play a crucial role in unlocking the secrets of the cosmos. Other upcoming missions, like the European Space Agency's Ariel and NASA's Roman Space Telescope, will provide further insights into the nature of exoplanets, dark energy, and the large-scale structure of the universe. Together, these missions will form a comprehensive view of the universe's past, present, and future. While some of the theories and models may be challenged or replaced, the scientific method remains steadfast in its commitment to the pursuit of truth. The willingness of scientists to question long-held assumptions and revise theories based on new evidence is what drives progress in the field. The discoveries made by the James Webb Space Telescope are a testament to the spirit of scientific inquiry. They remind us that the universe is far more complex and mysterious than we can yet fully comprehend. As the journey of discovery continues, the implications of these findings will extend beyond science, influencing philosophy, theology, and even our understanding of humanity's place in the universe. Each new discovery, no matter how small, adds another piece to the puzzle of our existence. The cosmic revelations we are witnessing today will undoubtedly inspire future generations to ask even deeper questions and seek even more profound answers.